Hey grade 9, so this is your first video lesson. Make sure you take your notes. So example 1, exponents. Find the integer equal to 3 to the power of 4, and then 2 to the power of 4 times 3 to the power of 2 times 7. So this should be a review from grade 8. You should get 81 and 1008. If you use the calculator for this example, that is okay. So a review, 3 to the power of 4 means you multiply 3 4 times by itself. So 3, 3, 3, 3. That equals to 81. So that notation there, it's the exponential notation. Alright. Second example, go ahead and do this. So let's go back to prime factors. Let's see if you guys remember this. So write 144 and then 4,312 as a product of prime factors in index form. So index form is this form here. 3 to the power of 4. Or 2 to the power of 4 times 3 to the power of 2. Alright, so if you are familiar with the prime trees, or if you like this version better, whichever, but make sure that you are writing the prime factors. One of the biggest mistakes are people are forgetting some of the factors, or they include like 4, right? But make sure that if you multiply these out, you get this. So 144, if you write it out as a product of prime factors, you get to the power of 4 times 3 to the power of second. Okay, and then 4,312 turns out to be, okay, I'm missing some of my numbers again. 4,312 equals to 2 to the power of 3 times 7 to the power of 2 times 11. But what I did was here, before it was erased, I did the prime factor tree. But you guys can always check with your calculators if you got them right. Alright. So which one is the product of prime factors? Which one is the index form? So okay, let's make this, let's make sure that you guys know the difference. Prime factors is this one here. Make sure that they are prime, so 2 and 3 are prime numbers, and they're factors. So index form is this form right here. You have a base and you have an exponent, or the power. Alright. Okay, so I want you guys to attempt 1, 2, 3, 4 of these examples. So we have negative bases. They all look kind of similar, but they have different placement of the parentheses. So I want you guys to try them out. Okay, so y'all should get 16 for the first one, negative 16 the second one, negative 32 on the third one, and positive 32 on the fourth one. So let me explain to you why these are different. Okay, so the first one, 3a, there's a parentheses around the base, right? So that means that thing inside of the parentheses, we multiply it by itself 4 times. So we get 16. Okay, so B here, it looks similar. It says negative 2 to the power of 4, but there are no parentheses. So what does that mean? That means we have negative outside, negative 1. Remember the invisible math. Negative 1 times, there's a parenthesis, an invisible parenthesis around the 2. So negative 1 by itself, and then 2 by itself, to the power of 4. What we're repeating, what we're multiplying by itself is 2, not the negative 1. The negative 1 is outside by itself. So we multiply that out, that's negative 16. Alright, and C here is similar to A, right? There's a parenthesis around the base. So you get negative 2 multiplied by itself 5 times equals to negative 32. Alright, 3D is a bit different because now we have a negative outside of the parentheses to the power of 5. Again, the number inside of the parenthesis is what you multiply by itself to this power number here. So negative 2 multiplied by itself 5 times, that's negative 32. And then don't forget the negative outside becomes positive. Alright. Okay, so this is the awesome part about grade 9. Starting grade 9, you guys have this awesome, expensive calculator called TI-84. You might have the plus, you might have the CE, whichever, they're both good. So I want you guys to practice, this is your first practice, pull up that calculator, and I want you guys to practice calculating 6 to the power of 5, and then negative 5 to the power of 4, and then negative 7 to the power of 4. Okay. So on the screen here, I'm going to help you guys out on how to find these answers here. Okay, let's start with 6 to the power of 5. That's easy. So what you do is press 6 and then the caret top. The caret top is below the button clear. So caret top. And then you press 5. And then you press enter. Enter is on the right hand corner. On the bottom right hand corner. So we got 7,776. If you watch the exponential video, you can tell that exponential function, it increases faster than a linear function. So yeah, it represents our COVID cases, right? So it makes sense that 6 to the power of 5 is 7,000. Yeah. All right, so how do we do parentheses, negative 5, close parentheses to the power of 4? So the parentheses are above 8 and 9. So the parentheses, and then the negative, okay, make sure you see this. The negative button is not the one above the addition button. The negative button is the one below 3. Okay, there's a difference. The negative button below 3 is a sign, positive or negative, right? Like negative. But the minus sign above the addition sign, that is an operation. So there's a difference. Be careful there. If you see an error, that's probably you put the subtraction sign instead of the negative sign. Okay? So negative, and then 5, close parentheses, and then caret top again, and 4, and then you enter. And as expected, it should be positive 625. So let's talk about the error message. So for example, if instead of I push the negative sign below 3, I push the subtraction sign. As you can see, the subtraction sign is way longer, right? And that's wrong. And then 5 to the power of 4. As you can see, it says need something before sub. There's an error message there. That means your negative sign is the wrong one. Okay, that's what I'm talking about. Alright, so the third one, I want you guys to do that on your own. Which one do you think is negative 7 to the power of 4? Is it a negative answer or is it a positive answer? What do you think? So let's try it out. I'm just going to punch it into the calculator. Let's see if the calculator got it right. So negative sign below the 3, and then 7, caret top, and then 4, enter. Yes, the calculator get it right. It's negative 2,401. Again, this means you have negative, there's an invisible parenthesis around the 7 to the power of 4. So I could have put negative parenthesis 7 to the power of 4. I'd get the same thing. Alright, so that was a fun closing of our video today. Or not. We have, let me see. Okay. We have 2 more pages. Never mind. Alright, chapter 6b. Laws of exponents. And again, this is a review, so that's why we're moving really fast. So what does the expression 2 to the power of 3 really mean? What about 2 to the power of 5? You guys know this already. So 2 to the power of 3 means 2 is multiplied by itself 3 times. So is 2 to the power of 5 multiplied by itself 5 times. So what do you guys think? Do you remember? If we multiply 2 to the power of 3 times 2 to the power of 5, what would it be? And is there a pattern? If you said yes, there is a pattern, you are right, because this is the pattern. You lay it out, multiply them all by each other. So this equals to 2 to the power of 8, because there are 8 2's on the screen there, multiplied by itself, right? Right. So how about division? What if I say 3 to the power of 9 divided by 3 to the power of 4? What's the pattern? You should lay it out like this as well. And this is my favorite part actually about exponents. I just slash it out because 3 divided by 3 is 1. Sometimes I do this, and then that equals to 1, that equals to 1. So we're left with 3 times 3 times 3 times 3 times 3. There are 5 3's up there, and then on the bottom is 1, but I'm not going to write that. So 3 to the power of 5. So what's the pattern? What do you guys see there? You should have said, if we're multiplying, we're adding the exponents. If we're dividing and the bases are the same, we're subtracting the exponents. Voila, that's easier, right? But if you forget the rules, you can pretty much figure it out on your own, like that. Alright, let's see if you remember this one here. So how about 5 to the power of 2? And then we also want to raise that to the power of 3. So this is how I do it. I lay it out if I don't remember the rule. But you can figure it out here. So how many 5's are there? Turns out there are 6. So you can guess it without even knowing the rule, right? You can say when power to a power means you multiply the powers together. Easy. Right. So how about this one here? So what if there's a multiplication instead of the parentheses, and then I raise it to the 5th power? What does that mean? So again, I lay it out. I'm going to count how many 2 to the power of, how many 2's there are, and how many 5's there are. I mean 3's. Okay, there are 1, 2, 3, 4, 5. And then there are 1, 2, 3, 4, 5. So that means the powers go to each base. Alright. So what if there is a fraction inside? What does that mean? Again, I'll lay it out if I don't remember. You can just count the 2's and the 3's. And it turns out it's kind of the same thing, even though it's multiplication or division. The powers go to each base there. Okay? Again, that should be a review for you. So let me summarize this whole thing here. So here is our exponential rules, exponential laws. You can take a picture of it, put it down in your notes. These all should be a review. Alright, this is your turn now. Try it out. And you should get x to the power of 9 and x to the power of 20. You add the exponents up when it's the same base and multiplying. Power to a power, you multiply the powers. Alright, how to remove the brackets of these, aka how to simplify it. Go ahead. And you should get these answers. And then you might ask, why is it 8x to the power of cubed? Because 2 to the power of cubed is 8. So again, it has to be fair, right? No child left behind, no variable left behind. You have to do it to each base. You can also think about it as this: 2x cubed times y cubed. And you can expand it. Again, that's at 8x cubed, y cubed. Okay, last but not least, express in the simplest form without brackets. Like what I said before, no variable left behind, no constant left behind. You have to do it to all. Raise them all up. There you go. I hope you remember those, and we will do some activities in class. See you guys.